I've got an entire vehicle to restore. I don't have time for this. The alternator was supposed to be a quick teardown, clean, replace the bearings and brushes, a few minutes of sped up footage, a couple of cheap shots at Lucas, and move on. But nothing is ever that easy. I have no idea why this nut is so tight. You're only seeing a fraction of the struggle. This is where things start to go awry. The stator should just fall out, maybe with a little tap. But you can see the alternator has taken a hit during its life. Ah, shit! Ah. Oh, shit. This is the first unanticipated challenge to deal with. Look at the key. It has almost sheared in two. I have a new key, so that's no problem. But the slot is also stretched. So here's the setup. The saddle and cross slide are both locked down. and I feed in very gently. At this point I realise that the clamp is going to clash with the shank of the cutter. No problem, I can reposition the clamp slightly without pulling apart the setup. It was going so well. The setup is relatively repeatable, so all I had to worry about was rotating the shaft to align with the keyway. The depth isn't affected, and the position along the shaft is set by the fact that the rotor is hard against the edge of the milling attachment. So no problem, on we go. Looks like I overshot the depth. I checked my maths, and all of that was okay. I have problems with the cheap micrometer mag base sometimes. I think it probably drifted during the cut. No big deal, I'll add a shim underneath the key, just to bring the depth up when I reassemble it. I decided to zinc plate all of the parts that had turned crusty. It's an easy but slightly time-consuming process. First, the parts are cleaned. I use an ultrasonic cleaner, and people always ask about it. It's not a magical device. In fact, they do very little. But I have it, and I'm lazy, so I use it to save a little scrubbing. And then everything goes into evaporust overnight. The fan needed a little extra work. And I deleted the vice marks I made. Next, everything goes into hydrochloric acid. The rectifier was actually pretty corroded. This is only a $12 part, so I decided to see if it'll survive being replated. I doubt it, but let's find out. And here is everything straight out of the acid. Normally you'd not expose anything to the air at this point, because it'll flash rust, but I had to split the process in two. So we'll re-dip the parts in acid to deal with any flash rust right before plating. So this is the process. Into acid, rinse off in tap water, rinse in distilled water, and then into the plating bath. I'm going to quickly resurface the slip ring. It's not too bad, and I wouldn't attack it with sandpaper by hand, because scratches across the line of the brushes are probably worse than the wear already in it. But since I have a lathe, I may as well give the brushes a fresh start. And there we are. Let's put it all back together. An alternator is basically three parts. There's the spinny thingy, the regulator, and the rectifier. The rotor is an electromagnet. It spins inside the stator and generates electricity. But it's only magnetized when current is passed through it. No current equals no output. That's why you can't crank start most vehicles if the battery is completely dead. And the more current that is passed through an electromagnet, the stronger the magnetism. And in the case of the rotor in an alternator, the stronger the magnetism, the more power the alternator will produce. So that's where the regulator comes in. It senses the power draw from the vehicle and adjusts the amount of current going through the rotor, which adjusts the amount of power being generated by the alternator. So all of that power is generated in the stator windings. In this case, there are 3 windings, which means 3-phase power. The power being generated is alternating current, which is useless to us. So that's where the rectifier comes in. It converts the wild AC current into nice clean 12-volt DC for use in the vehicle. Now let's check if all the bits are working. I can't test the regulator. At least, I don't think I have the equipment to test it. But I haven't done anything to it apart from spray a coat of paint on the outside of the case, so let's assume it still works. The rotor first. We're looking for open circuit between the windings and the body of the rotor. And according to the book, about 3.3 ohms across the windings. For the stator, again we need open circuit between the windings and the body or rings of the stator. And the resistance across each combination of windings should match each other. Now, the rectifier. So basically, we have gnarly 3-phase AC coming into each of these 3 terminals. These 3 tabs are where the plug attaches to feed the vehicle. Ignore the fact that there are 3 tabs. That's just a coincidence. 2 of the tabs are just branched off the middle plate. Each terminal is connected to 3 diodes, through to all 3 plates, and the plates are isolated from each other. Now, I may have this a little wrong, but this is the gist of what's going on, for us laymen. A diode is basically a one-way valve. If the current is flowing in the direction of the diode, it gets through. If not, it doesn't. The alternator is generating AC current. If we put a diode into an AC circuit, it will split the current. And the pros show AC current in waveform. So basically each diode is letting through 1/2 of the wave. The output is pulsing DC current. But our alternator is generating 3 phases. So when all 3 phases combine, we get relatively smooth 12-volt DC output. To test that the diodes are okay, we want to see the same voltage through each diode. So you can see the diode connecting this terminal to the top plate is letting about 0.49 volts through from the multimeter. The diode connected to the second plate is showing the same. But the third plate is showing open circuit, so it's either a bad diode or the diodes connecting to the third plate are the other way round. If the diodes are working properly, when the current is reversed, we should get the opposite result. About 0.49 volts on the bottom plate and open circuit on the other two. I think this part number, which is just called sundry parts, is supposed to include the little red plastic thing covering the wires and also a new slip ring. But it doesn't actually say that anywhere, and I was only supplied with the bearing. It's just a basic cheap bearing, and both bearings are the same. So just buy the bearings, or buy two of the sundry items for the front of the alternator, which includes the same bearing and costs a few dollars less. This old bearing was really crusty. And this is the sundry parts for the drive end. There are two washers that go on either side of the bearing. One is thin and one a bit thicker. I couldn't for the life of me get the snap ring in when using the thick and thin washers. I think the new bearing is slightly thicker. Anyway, I got it to work by using both of the thin washers, new and old. And this is where I hit a roadblock. The stator really doesn't want to go back into the housing. Remember, this is the half that had taken a hit. It went in with a bit of tapping, but there's a problem. The rotor is catching on the stator. I guess because it's being forced out of round by the damaged housing. I thought I might get away with taking a shaving off the inside of the dented section with just a file, but no. A new alternator only costs about as much as one tank of gas, so I don't want this to get out of hand. I'm not going to remachine the housing, but I figured I'd quickly try shaving a bit off in the lathe. So I'm centering the housing just by pressing a center up against the bearing. That's as good as it's going to get. And then I rotate the housing by hand, hopefully knocking off the high spots with the lathe tool. That definitely helped. I went back and forth about 4 or 5 times. The housing was really far out of round. Probably a couple of millimeters. In the end, I cut probably more than half of the circumference. And you can see that the stator now slides in with just a little friction. And the rotor spins without any scraping, so I'm calling that good. And nice new brushes. The new brushes are about double the length of the old ones. Taking these screws in and out to get the wires in the right combination was a little painful. Lucas used posi-drive screws, and I don't have a driver for them. They also used 4BA screws to hold the brushes in. I do have a 4BA wrench, but it's still painful. I'd like to use a new nylock nut in place of the old heavy spring washer. That way it doesn't need to be tightened by the guy down at the tyre centre with his largest rattle gun on full blast. The nylock nut is a little deeper, but it's going to work okay. New old stock. Santana mixed with Lucas. The pinnacle of reliability. Recambios originales. Oh, come on. And there we go. That was a little more involved than I was intending. But I prefer to see if the original parts can be kept. In saying that, I will be carrying a spare alternator,